This video is made possible by Brilliant. You're going to learn more about Brilliant later in today's video, but if you'd like to get started right now, go to brilliant.org/biographics. You'll also find a link in the description below. Sir Isaac Newton is regarded as one of the greatest scientists who ever lived. His breakthrough idea about motion influenced every area of physics, allowing other great thinkers to stand on his shoulders. Yet Newton was also a man at odds with his public perception, a secret alchemist and a heretic who risked his life to write about the failings of the Anglican Church. In today's biographics, we're uncovering the truth about the real Isaac Newton. Isaac Newton was born on January 4th, 1643 in Woolsthorpe by Colsterworth, a small town in the country of Lincolnshire in England. He was a premature baby who was so small that his mother said that he would have fit inside a quart mug with room to spare. The doctor who delivered him didn't think that he'd survive his first week. Newton's father, who was also named Isaac, had died 3 months before the child was born. He had been a successful farmer, and his wife Hannah was left a financially comfortable widow. For the next 3 years, she raised young Isaac alone. Then, in 1646, she remarried, becoming Mrs. Barnabas Smith. The relationship between young Isaac and his stepfather, it was a difficult one, and the boy spent a lot of time in the care of his grandmother. Hannah and Barnabas went on to have 3 children together, Benjamin, Mary, and Hannah. Isaac seems to have gotten on well with his half-siblings, though his relationship with his mother was tempestuous. When he was 19, Isaac wrote a list of sins for which he wanted to repent. One of them was threatening to burn down his family home with his mother and stepfather inside it. Isaac attended a village school sporadically, but he didn't begin his formal schooling until the age of 12 when he enrolled at King's School in Grantham, England. Initially, he showed little interest in his studies and performed poorly in all subjects. However, all of a sudden he had something of an attitude change, and he decided to apply himself more seriously. When he was 17, Isaac's stepfather died. His mother, looking to her oldest son's potential as the family breadwinner, attempted to make a farmer out of him, but Isaac had no intention of becoming a farmer. In fact, he detested the very thought of spending his life out in the fields. Fortunately, after a few months, the master at King's School interceded on Isaac's behalf, convincing Hannah that he was best suited back with them. Isaac had been bullied by another student and chose to respond by outdoing the bully and his cronies academically. Isaac achieved outstanding academic results. He was the top-performing student of 1660, displaying an amazing aptitude for all subjects. In June of 1661, Isaac began studying at Trinity College at Cambridge University. In order to pay for his studies, he worked outside of his study hours, serving meals and running errands for his professors. The 18-year-old had entered Trinity with the goal of becoming a minister of the Church of England. However, at some point within that first year, he changed direction. It is unclear why he decided not to pursue a life in the church, but from his later writings it was clear that he was forming beliefs about God that were rather at odds with the doctrine of the Anglican Church. The foundation of the education that Newton was receiving at Trinity College was based on the teachings of Aristotle. He was fascinated with these ideas, but objected that many of the concepts were not based on evidence, but merely on the great philosopher's assumptions and his ideas. Newton became increasingly focused on the natural sciences as well as philosophy. He studied the works of such original thinkers as Descartes, Kepler, and Galileo. Because the establishment had not accepted the scientific findings of these men, Isaac did a lot of his study outside of the classroom. Newton absorbed scientific ideas from wherever he could get them. So long as he was able to test and prove them, he would take these ideas on board and then debate them with his professors and fellow students. In 1662, Newton filled the pages of a notebook with a list of 45 things he wanted to study. They came under the general heading of physics, but unlike everyone else who had gone before him, Newton didn't just pose the questions, he also set out to answer them. He began to devise experiments in order to find the answers that he was looking for. The following year, however, Newton's focus was pulled away from his list of physics-based questions. He became fascinated with the works of René Descartes, and this led him to an in-depth study of mathematics. Descartes applied the Arabic discipline of algebra to geometry and called it algebraic geometry. Newton graduated from Trinity College in August of 1665. He did not receive the stellar grades that his talents merited, which was probably due to the fact that he spent so much time on his own personal studies. At this time, all of Europe was being ravaged by the bubonic plague. In London, 1 in every 4 people died. Colleges were closed down in an attempt to control the spread of the disease. This postponed Newton's continued formal education, but he made great use of the time. For the next 2 years, Isaac focused on his personal studies from his family home. His main areas of study were calculus, lunar motion, and optics. He now had the time to mull over all of the knowledge that he had accumulated at Cambridge and relate this to the world around him. This led him to more questions, 3 of the most fundamental of which were: why do things always fall down? Why doesn't the moon fall to Earth? And why do planets stay in orbit? Newton was convinced that mathematics would lead to the answers to these questions. He developed a new form of maths, which he called fluxions, the basis of modern-day calculus. He later wrote about this time in his life: "At this time, I was in the prime of my age of invention and minded mathematics and philosophy more than any time since." Newton returned to Cambridge in the spring of 1667. He had developed into a rather peculiar 23-year-old man. He was a loner with no friends. He was content to spend hours on end just with his thoughts. Many people dismissed him as just being an absent-minded recluse. None of his contemporaries had any idea that he was grappling with an understanding of planetary motion. He took up a position as a fellow of the college and held a number of prestigious positions over the coming years. In 1669, Isaac published his first work, which was called Analysis by Infinite Series. It was an investigation of cubic equations and curves in 3 dimensions and was well received in the wider scientific community. As a fellow of Cambridge, Newton was expected to become an ordained priest in the Anglican Church, but his opposition to the belief in the Trinity doctrine held him back. When he was appointed as Lucasian Professor of Mathematics, though, college officials pressed for his ordainship. He managed to put off the requirement, and he received the promotion. Now aged 27, Newton held one of the most prestigious positions in the mathematical world. As Lucasian professor, he was required to lecture on mathematics and place copies of his notes in the university library, a requirement which he rarely complied with. He began lecturing on the subject of optics, with his notes forming the basis of his book, Optics. His work on optics led Newton to focus on improving the working of the refracting telescope. He was grappling with the problem of how to get the different colors of light to come into focus at the same spot on the lens. He failed to solve this issue and so turned his attention to the reflecting telescope. In 1668, Newton produced the first working reflective telescope, building on the work of Scottish mathematician James Gregory. He used his telescope to look into the night sky, where he was able to observe the 4 moons of the planet Jupiter. In 1671, Newton was nominated as a member of the British Royal Society. To support his proposed candidacy, he wrote a letter on the nature of light, which was read at the Society's next meeting. It caused mixed reactions, with some praising his observation and others vehemently opposed to it. Newton was admitted to the Royal Society in 1672, marking his entry into the legitimate scientific community. Up until then, he had done his work in isolation, but now he was rubbing shoulders with the most prominent scientists in the world. Isaac immediately came to loggerheads with most of the respected members of the Royal Society. Robert Hooke was the curator of experiments for the Society. Unlike the quiet, reserved Newton, Hooke was loud and outgoing. He objected to Newton's writings on the nature of light, which challenged the conventional wisdom. Over a period of 4 years, Hooke wrote 10 published objections to Newton's ideas, each of which were countered by Isaac. Newton hated the constant quarreling, which was a part and parcel of being a member of the Royal Society, and after 15 months, he quit the organization. The secretary of the Society, Henry Oldenburg, pleaded with him to stay, assuring him that he was greatly respected. But Newton stayed away from the Society for the next 2 years. By 1675, Newton's refusal to take the priesthood was becoming a serious problem. It was becoming a talking point which was proving embarrassing to the college. With it looking as if he would lose his position, he turned to his mentor and former Lucasian professor, Isaac Barrow, for help. Barrow suggested that he write to King Charles II and request a special dispensation allowing him to continue in his position without entering the priesthood. Newton was generally dissatisfied with the way that the Anglican Church had evolved. It maintained many of the trappings of the Catholic Church, which he objected to, but his biggest problem was with the doctrine of the Trinity. He could not accept that God and Jesus were one. In March of 1675, Newton travelled to London to file for a special dispensation. To his relief and surprise, it was granted without question. In fact, the king removed the priesthood requirement for all future Lucasian professorships. In November of 1680, a bright comet appeared over the skies in England. It was tracked and commented on by the leading scientists, including Newton and a new Royal Society member named Edmund Halley. In 1684, the two men got together to discuss the shape of the orbits of planets. Halley was impressed with Newton's ideas and persuaded him to present his works in written form to the Royal Society. Now, just before we get into the rest of Newton's life, I do want to take a moment to thank the people who make this video possible, and that'd be brilliant. And I know these mid-roll ads, they're not great for the story here, but these videos are long, so I hope you appreciate our need to have sponsors to make them possible. They're pretty expensive and time-consuming to produce. Now, Brilliant are a learning platform which teaches through something called active learning. Unlike biographies, which are a nice way to learn about people's lives like Newton, learning about science, it's a little bit trickier. I don't know if you've ever had to sit down with a science textbook. I have, and there's sure a lot of moments where it's like, what? I don't really understand what's going on, and then you read it again and you still don't get it. This is passive learning. It's not what Brilliant is about. Brilliant have active learning, and they give you something super short to read. It's really easy, and then you can immediately apply that to a problem. You just rinse and repeat that, and suddenly you're understanding all sorts of stuff that you didn't think you would be. I've used Brilliant, and I think you should go try it out just to see how fascinating it is that a complex subject can be grasped quite so easily. Obviously, with this biography about Newton, they've got lots of stuff related to what he was up to, so nice tie-in there. You can support Biographics by going to brilliant.org/biographics. And let's get back to Newton. For the next 18 months, Newton was consumed with the writing of his masterwork, which he called Principia Mathematica. He was so absorbed with it that he often neglected to eat or sleep. In this 3-volume work, he brought together the results of 20 years of study, observation, and thinking about nature. He began by laying out a series of definitions that underpinned his thoughts on the natural world. These definitions for such things as inertia, matter, mass, and momentum, they still stand today. With his basis established, he then laid out his 3 laws of motion: the law of inertia, the law of acceleration, and the law of action and reaction. These in turn led to his most groundbreaking idea, the law of universal gravitation. The law of gravitation, it flew in the face of Aristotle's 2,000-year-old teaching that the Earth operates under one set of rules, while the sun, the moon, planets, and stars, they follow different rules. According to Newton, there was one law that governed the motion of everything in the universe. The Principia was presented to the Royal Society in 1686. Robert Hooke immediately accused Newton of plagiarizing his ideas. Despite this, the volume it was well received. When it was published a year later, it became an instant masterpiece. The law of universal gravitation was accepted as the breakthrough that explained everything from the motion of the planets to the tides of the sea. Despite the popular reaction to Principia, Newton's ideas, they would not be taught in universities for another 50 years. When he was a student at Cambridge, Newton had first come into contact with alchemy. This pseudoscience had its origins in the works of Aristotle, who taught that all matter was composed of 4 basic elements: earth, air, fire, and water. By adjusting the proportions of any of these components, it was believed that one thing could be turned into another. Aristotle also taught that each of the elements was connected to a human emotion or a characteristic. Newton was fascinated with these concepts, even though they were completely at odds with the rational, evidence-based way that he synthesized his scientific ideas. From that time onwards, he led a sort of double life where he portrayed himself as the ultimate logical thinker while pursuing unorthodox alchemist experiments away from prying eyes. At the same time, he also developed a number of religious views that were decidedly outside of the mainstream. Starting in 1669, Newton built up an extensive library of alchemy-related books. He was obsessed with finding universal truth and saw alchemy as a means of doing so. He wrote thousands of words of notes on the subject and conducted hundreds of experiments. His information, it was eventually condensed into a book which he called Clavis. Newton had a deep and abiding interest in religion. Over the course of his life, he wrote more than 1 million words on the subject, but very few of them were actually published during his lifetime. Through his studies of the Hebrew language and careful study of the scriptures, he became convinced that modern Christianity was not following the model that had been set out by Jesus. Newton fundamentally disagreed with the doctrine of the Holy Trinity. At the time, this was an act of heresy punishable by imprisonment or even worse. By writing about it, even if his work was unpublished, he was putting his very life at risk. Two important works of scriptural interpretation that were published in the century after his death were Observations on the Prophecies of Daniel and the Apocalypse of St. John and The Chronology of Ancient Kingdoms Amended. Newton was fascinated with Solomon's Temple, believing that the building was a paradigm for the universe and a pattern for the future of the human race. It was his belief that the architecture of the temple held secrets to uncovering the mysteries of the universe and revealed a future Bible prophecy. From it, he gave predictions about the end of the Catholic Church, the return of Christ, and the Day of Judgment. In 1687, Newton became involved in a conflict between King James II and Cambridge University. A Benedictine monk had requested a receipt of a master's degree without having to swear oath and allegiance to the Anglican Church. The monk appealed to the king, who issued a mandate stating that the university must admit the man without requiring the oath. Newton came out on behalf of the university and was soon appointed to represent them at a commission hearing at Westminster. His arguments proved persuasive, and the monk was not admitted to the university. In January 1689, Newton was elected to public office when he became the university's representative in the Convention Parliament. With his new position came a change in personality. He transformed from an introverted, retiring academic to a friendlier, more outgoing public servant. In 1690, Newton suffered a period of depression and mental exhaustion, apparently compounded by a dose of influenza. He recovered and spent the 1690s focused on the moon's orbit. His work required that he obtain astronomical readings from the first astronomer royal, John Flamsteed. But the two men, they did not get on. They quarreled from the very start, with the relationship eventually completely breaking down. This meant that Newton was unable to complete his investigation into lunar cycles. In 1696, Newton sought a higher-paying job in the public service. He was awarded the position of Warden of the Royal Mint. This job required a move to London, which is where he actually lived until his death. He oversaw the recoining of old silver and gold coins. He also standardized the weight and composition of coins so that he was able to bring British coinage a much greater degree of accuracy than was ever known before. 3 years into the job, he was promoted to Master of the Mint. The job, which he held until his death, paid around £1,500 a year, which was a huge amount for the times. In 1703, Newton, now the most famous scientist in the land, ascended to the presidency of the Royal Society. He held this position until his death. In 1705, he received a knighthood from Queen Anne. However, his acclaim among the scientific community was strained with an ongoing dispute with German polymath Gottfried Leibniz over which of them should get the credit for the invention of calculus. Although Newton was the first to develop the basic concepts, Leibniz published his work on calculus before Newton. The issue divided the leading scientists of the time. During the last 2 decades of his life, Newton spent a great deal of time revising his most famous work, Principia Mathematica. A second edition was published in 1713, with a third and final version appearing in 1726. He also indulged a passion for biblical study, spending days on end compiling notes on the history of the ancient Hebrews. It is clear that Newton was keen to ensure his legacy lived on beyond his physical years. He sat for a number of portraits, and sculptures were cast of him. Still, though, he professed an outward appearance of humility, making the following statement: "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in, now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me." The last years of Newton's life were spent with his niece, Catherine Barton Conduit, and her husband. In his 70s, he began to suffer from breathing problems, prompting a move from London to Kensington, where the air was fresher. In 1725, at the age of 82, he was confined to his bed with severe lung problems. Coughing fits were constant, and he suffered from an uncontrolled bladder. By early 1727, he seemed to have recovered somewhat. He actually felt good enough to preside over the Royal Society meeting on February the 28th, but that effort, it was too much for him. Upon his return home, he was again confined to bed. In early March, his doctors diagnosed a kidney stone, and his condition steadily worsened throughout that month, and he passed away in the early hours of March the 31st, 1727. Newton was awarded the great honour of being buried at Westminster Abbey. His funeral service was the most extravagant ever held in England for a natural philosopher. So I really hope you enjoyed that video. If you did, please do give us a thumbs up below and don't forget to subscribe. We've got brand new videos several times a week. If you're looking for something else to watch right now though, why not check out some videos from the archive that are linked to on the screen now. And as always, thank you for watching.